Good morning, students. Today I start a new topic of your subject of mathematics, that is relation. It is a very good topic for the 11 students and 12 students and JEE advanced students also. Before I start the topic of relation, first we describe the introduction about relation. Just to see, my dear students, a relation. Before start of the topic relation, first just you see 2 plus 5 is equal to what? 7. 2 plus 5 is equal to 7. 2 into 5 is equal to what? 10. 8 division 4 is equal to 2. What is that? This addition, multiplication and division. What is that? This addition, multiplication, division and division and also subtraction is represented as binary relation. Is represented as binary relation. Just you see, when we add two numerics, we get and we add two numerics, it is what? It is 7. That addition is represent a relation between two elements 2 and 5. Similarly, product or multiplication is a relation between two numbers 2 into 5 is equal to 10. Similar way, it is represented as binary relation. Just you see, 2 less than 5. This less than symbol, 5 greater than 1, the greater than symbol, and 2 equal to 2. This less than, greater than and equal is basically represented as relational operator. Relational operator in mathematics. So, when we think about a concept of relation, we already know the different type of operations in numeric: addition, subtraction, multiplication and division, and also different type of relational operator: less than, greater than and also equal. Just this is my example 1 and this is my example 2 for discussion related to a relation. Let us take another example. What is that example? Just Dasarath is the father of Ram. Labba is a son of Ram. Ram is a son of Dasarath. Just you see this example. Please. Dasharatha is the father of Rama. That means Dasharatha is associated to Rama with a relationship of father of. See, another example. Labba is a son of Rama. That means Labba is associated to Rama with a relation of son of. Similarly, Rama also son of Dasharatha. That means here we understand that when we develop a relation, at least two elements are to be required with a associationship. That means it is a father of and also son of. That means Dasharatha, Rama, and Labba, Ram, and Ram and also Dasharatha. From this order pair, Dasharatha is associated with Ram with father of, Labba is associated to Ram with son of, Rama is associated to Dasharatha with also son of. This type of associationship between two elements is also develop a relation. In this way, a relations are to be developed in case of different type of operations. In case of different type of operations, and these operations is a development of a set theory. Development of a set theory. Here, in example 1, I describe myself different type of binary operation. In example 2, I am describing different type of operational operators, less than type, greater than type, and equal. In my third example, I describe a fractional relationship like father of, son of, Dasharatha, just like example, Dasharatha associate Rama, Rama associate Labba, and Labba associate Rama. This type of examples are day by day. It is under the function of set theory. Just you see what is the definition of a relation. Just you see, let A and B are be the two non-empty sets. That means A and B are to be the two non-empty sets. Then RBA set contains order pair. Pairs which is subset of A and B. Then R is known as a relation from A to B. This is the definition of a relation. What is that? Just you see, let A and B be the two set. And if this is two set, then RB also set contains element of set A and contain elements of set B with the form of order pair. That set R having some order pairs, that R is also subset of A cross B. Then R is known as relation. Just you again, all of you write it again. We also develop let A and B be the two sets. Then any subset of A cross B, that means R is a subset of A cross B. R is a subset of A cross B. Here R is a relation. Here R is a relation. Just to see, if A and B be the two set, then we develop A cross B. If R is any set and R is a subset equal to A cross B, then R is known as relation. Here R is a relation. That means any subset of A cross B is a relation. Any subset of A cross B is a relation. So here we finally develop the relation like a relation is a subset of A cross B. That means R is a subset equal to A cross B. Second is a relation is contain order pairs. Or relation is contain order pair. Or any subset of A cross B is also A is also a relation, is also a relation. So we personally feel that a relation is basically subset of A cross B, or a relation always contain order pairs, or any subset of A cross B is also a relation. For example, just you see, suppose I have a set A having element A, B, C, D. I have another set B having element A square, B square, C square, D square, E square, and also F square. Right? So here we choose a set R which is A, A square, B, B square, C, C square, and D, D square. These are is a subset of A cross B. These are is a subset of A cross B. That means here R is known as what? A relation. Here R is known as a relation. Just you see, suppose I have a set A, I have another set B having element A, B, C, D, and B having A square, B square, C square, D square, E square, and F square. The element of set A is associated with A square, element of set B associated with B square, element of C associated with C square, element of D is associated with D square. That means A is associated to B as a square of relationship. That means R is a square relation from A to B. Just you clear? This is my example 1. That means here we feel R is a subset of A cross B. That's why R is a relation from A to B. Again, we take one more example. Just you see, what is my example? This is my example 2 again. A having A, B, C, D, B having A square, B square, C square, D square, E square, and also F square. Then we choose R is a relation from A to B. That is B square, and C square, and A E square, and A F square. Just you see, what is the relation? The relation is R is a subset equal to A cross B. Here R is also a relation. Here R is also a relation. Clear? This is my example 2. Because R is a subset equal to A cross B. That means first we derive the number of subsets. First we determine A cross B. Then you choose any subset from A cross B. Then according to our definition, any subset of A cross B is also a relation. Clear? We choose one more example here. Just you see, I have example 3. Suppose A is a set 1, 2, 3, and 4. B is a set 1, 4, 9, 16, 25. 9, 16, and 25. Here, first we find A cross B. What? A cross B means A product B, A Cartesian product B. That means Here we associate element of set A to element set B in a pair system, in a order pair system. What is the order pair here? Order pair 1 1, again 1 4, 1 associated to 1, 1 associated to 4, 1 associated to 9, 1 is associated to 16, 1 is associated to 25, like that. Then 1 into 4, 1 into 9, 1 order pair 9, 1 order pair 16, 1 order pair 25. Then 2 order pair 1, 2 order pair 4, like that, 2 order pair 25. Then 3 order pair 1, 3 is associated to 1, 3 is associated to 4, like that, 3 is associated to 25. Similarly, B is associated to 4 is associated to 1, 4 is associated to 4, like that, 4 is associated to what? 25. That means what is the total number of elements? Total number of elements A cross B elements. That means A modulus cross B modulus. How much it is? In A modulus, how much it is? 3. In B modulus, how much it is? 5. So A cross B modulus is 3 cross 5 is equal to what? 15. Then 15 number of elements are developed, but 15 number of order pairs are developed in A cross B. In A cross B, we develop 15 number of order pairs. Now we check, suppose R is a, we already defined R is the subset of A cross B. If we choose R is a relation from A to B, that is 1 1, 2 4 and 3 9 and 4 16, right? I am choosing R. R is just like. That means here R is a relation because R is a subset equal to A cross B. According to our definition, R is contain order pairs. Yes, it is okay. And R is a subset of A cross B. Yes, it is also okay because total number of order pairs is coming 15. But we am choosing 1 1, 2 4, 2 3 9 and 4 16. That is why it is a relation. How one is related to, so how first order element of first component of the element of order pair is associated to second, first component is associated to second component with square, 2 is square to 4, 3 square 9, 4 square 16. It is one example. This is suppose it is R1 relation. That means R1 is a subset equal to A cross B. Again we may choose, suppose R2. Suppose we choose R2. Here R2 is equal to what? Suppose I may choose 1 1, 1 4, 1 1 4, 1 1, 1 4 and 1 25. Right? Right or not? That means here R2 also subset equal to A cross B. R2 also subset equal to A cross B. If R2 also subset of A cross B, just you fill R2, how it is? This is the set, this is the set, this is A, this is B, 1 2 3 4, 1 4 9 16 and also 25. Here we see 1 is associated to 1, 1 is associated to 4, 1 is associated to 25. That means it is a relation of one many relation. It is example of one many relation. It is also another way to derive a relation. Here is the question, how many relations are developed from A cross B? How many relations are developed A cross B? Just you see, if we have two set, let we have two set A and B, and A has m number of elements and B has n number of elements, then A cross B has A modulus into B modulus, that is m into n, that is mn number of elements. Mn number of elements from A cross B. According to definition, any subset of A cross B is a relation. That means total number of relation is just, you see, if total number of relation is equal to the power mn, to the power mn, because we already know that if A has a m number of element, the total number of subset is equal to the power mn. If A cross B has a mn number of elements, so any subset of A cross B which is a relation, according to same rule, we derive to the power mn is the total number of relation from A to B. The total number of relation from A to B is equal to the power mn. Just to see an example. Just to see an example. Suppose A has 1, 2, 3. B has 6, 7 and 8. How much element A cross B has? A cross B has a 3 cross 3. That means 9 elements. What is total number of relation is equal to what? Total number of a relation. Just you see, to the power mn. Here it is. To the power mn means to the power 9. That means to the power 9 number of order pairs or sets are from developing, are to the power mn number of relations are to be formed in A to B. So a relation is a associationship between two or more element, right? Just you see, here we find that a relation, suppose A is a set, B is another set, A to B which is related A to B is making association between elements of set A and set B. This association is a relation that is are always subset equal to A cross B. R is a subset equal to A cross B. That is what? That is the definition of relation, as well as how to find the total number of relation from two non-empty sets. Okay, that is the definition of relation. Now here is the question: which is the smallest relation from A to B? Which is the smallest relation from A to B? You already know that phi is a subset of A cross B. If phi is the subset of A cross B, according to definition, phi is any subset of A cross B is a relation. That means phi also a relation. Phi is also relation, which is the smallest relation from A to B. Phi is the smallest relation from A to B. Similarly, every set is a subset of every set. If every set is the subset of itself, that means if A cross B is a set, is also subset of A cross B. If A cross B is a set, then automatically A cross B also subset of A cross B. If A cross B is the subset of A cross B, this form the largest relation. This form the largest relation. That means A cross B is represented as largest relation from A to B. A to B. Then we proceed to domain of relation. Then we proceed to domain of relation. We proceed to domain of relation. Domain of relation, what is that? Let R is a relation from A to B. Let R is a relation from A to B. And that means what? R is a subset equal to A cross B. That means what? R contains order pairs. So a domain of R such that X belongs to X comma Y belongs to R. X comma Y belongs to R and X belongs to A. That means all element of the order pair, all element of the order pair, which element from set A, that elements are represented as domain relation, that represent as domain relation. That means domain of relation we are from X, the X elements, that means X elements from set A and Y elements from set B. That is why those element of set A is associated with the element of set B, and that element is represented as X, and that X from A set. That is what? That are the domain relation. That are the domain relation. For you see, suppose A is a set, B be the another set, A is associated to B with a relation, and the element from X, element from set A is known as domain of A, domain of R, is known as domain of R, is known as domain of R. Just an example. Just an example. Suppose X is, suppose A is a set 1, 2, 3. B is the another set 4, 5 and 6. R is a set contain order pair 1, 4, 1, 5 and 2, 6. Right. So which is the domain relation? Domain relation is the first element of the order pair. First element what? 1. Second first element 1. Here also 1. Here also 2. So 1, 2. This 1, 2 belongs to A set. That means this 1, 2 element are represented as domain of relation, and these are is a subset of A cross B. Then this is also domain relation. This is also domain relation. Again, that means this is domain of relation. Then range of relation. What is range of relation? Range of relation. Range of relation. Let A and B are be the two sets, and R is subset equal to A cross B. R is subset equal to A cross B. Then range of relation such that Y such that X comma Y belongs to R comma Y belongs to B. That means those element of set A associated to the element of set B, that B element is represented as range of relation. That B element is represented as range of relation. For example, suppose A is a set 1, 2, 3, 4, B is a set 1, 4, 9 and 16. Then we develop a relation from A to B, element like 1, 2, 3, 1, 4, 9 and 16, 1 associated to 1, 2 associated to 4 and 3 associated to 9. That means 1, 2, 3 is the domain of relation, and the element of set A associated to set B. That means 149 is known as range of relation. Is known as range of relation. Okay, that means the set of A which are allotted to set B, that B elements are range of relation. The first element of set A which are associating, that is domain of relation. Okay, so I cover how a relation is developed. Again, what is the definition of relation? Again, what is the domain of relation? What is the range of relation? Again, we also inverse of a relation. Just you see what is the inverse of a relation. Inverse of a relation. Inverse of a relation. Let R is a relation from A to B, and R inverse is also relation from B to A. Okay, if R is a relation from A to B, then R inverse is also relation from B to A. Just you see, if A is a set, B is a set, A associate to B with a relation, if B associate to A, that also R inverse is also R inverse. That means in here domain relation belongs to A set and range relation also belongs to B set, but here domain in R inverse belongs to B set and range R inverse belongs to A set. A associate to B relation, when B associate to A, that is inverse relation. That means when R is a relation from A to B, then R inverse is exist from B to A. Just an example. Suppose A is a set 1, 2, 3, 4. B is the another set 1, 2, 3, 4. Then A cross B is a set contain 1, 1, 2, 2, 3, 3, 4, 4. Then R is a relation from A, 1, 1, 2, 2, 3, 3, 4, 4. That means R is a subset equal to A cross B. Here domain of R is equal to 1, 2, 3, 4 and range of relation is also 1, 2, 3, 4. This is a relation from A to B. Again, just you see R inverse. R inverse also is from B to A. That means domain of R inverse is also what? 1, 2, 3, 4 and range of R inverse is also 1, 2, 3, 4. That means here a relation and a relation from A to B as well as a relation from B to A are equal. Okay, this is one example. Again, another example. Just you see, suppose A is a set 1, 2, 3, 4, B is a set 1, 4, 9, 16 and 25. Just R is a relation 1, 1, 2, 4, 3, 9 and 4, 16. Here domain of a relation 1, 2, 3, 4. That means it belongs to A set. A range of a relation R is equal to 1, 4, 9 and also 16, which belongs to B set. Then we take R inverse from B to A. That means 1, 1, 4, 2, 9, 3 and 16, 4. That means DOM of R inverse is equal to 1, 4, 9 and 16. Range of R inverse is equal to 1, 2, 3, 4. In this way, we determine domain, range and inverse of a relation. My dear students, today my discussion is based on how relations are developed day by day, then definition of relation, range of a relation, domain of a relation and inverse relation. This is my part 1 of relation of your subject. Thank you.